Welcome to the deep dive. Now, if you're prepping for your certification, maybe you're focused mostly on, the wrenches, the circuits, but today we're really cracking open Chapter 14 of the AMT General Course Material. That's the chapter on human factors.
Right. And look, if you talk to anyone serious about aviation safety, they'll tell you this isn't just some theory chapter. It's basically the blueprint for keeping planes safe going forward. Our goal here is pretty straightforward. Quickly unpack why human performance, not necessarily the next piece of tech, is maybe the most critical piece for future aircraft safety.
I think we have to start with just how big this issue is. I mean, human factors didn't become a formal focus just because the data, it was inescapable, wasn't it?
It really was, and still is. The FAA really started formalizing things back in 1988. They held the first national conference just on this, and the data since then, staggering and consistent. Around 75 to 80%, give or take, of all aviation accidents come down to human error.
Wow, that high. That really forces you to rethink what an accident even means.
Precisely. Now, a lot of people, their minds jump straight to pilot error. And that's part of it, sure. But only about, say, 12% of that total figure is linked to maintenance. But here's the key thing for you as an AMT student. Pilot errors. They tend to be active failures. They happen, you see the result, often immediately, very visible. Maintenance errors, though, they're different. They're often latent, hidden, sneaky flaws baked into the system, just waiting.
Waiting for the right conditions.
Exactly. Waiting for the right operational stress, or maybe just enough time to pass before triggering something catastrophic. It's like a ticking clock hidden away, a deferred disaster.
So understanding these factors, it's really the study of prevention. Let's just clarify the terms the course uses. Human factors. What's the formal definition there?
Yeah, the manual defines it as basically optimizing how people perform and reducing their errors, all to get the highest level of safety possible. It's fundamentally looking at how people interact with everything around them, the tools, the procedures, the environment.
Okay, and the thing we're trying to prevent is human error.
Right, that's the unintentional slip-up. Performing a task, but doing it incorrectly in a way that can degrade the system's safety or performance.
And the book breaks that down into three types: omission, commission, and extraneous. So say I'm an apprentice, right? And I just forget to put a small access panel back on after I'm done. What's that?
That's a classic omission.
Yeah.
You just didn't do a required task, completely missed it. Now, commission would be if you did put the panel back, but maybe you cross-threaded the screws. You did the task, but incorrectly.
Yeah.
And extraneous, that's doing something you weren't supposed to do at all. Maybe putting in a part that looks okay, but isn't actually certified for that aircraft.
And the potential outcomes. They run the whole gamut, don't they? From basically nothing happens, maybe slight damage, all the way to personal injury or
Catastrophic failure, loss of life.
Right.
The stakes are incredibly high. And you've got to understand, the environment where AMTs work, it throws up a unique set of challenges you don't really see in other aviation roles.
Let's talk about that environment, because it sounds totally different from, say, a pilot's flight deck or an air traffic controller's tower.
Oh, it's night and day. AMTs are often working late nights, maybe early mornings. Right away, you're fighting your body's natural clock, the circadian rhythm. Then there's the physical space. You might be crammed inside a wheel well or working way up high on the platform, often out on the ramp, dealing with, freezing cold or sweltering heat and humidity.
That sounds tough. Physically demanding, but you also need intense focus.
Exactly. It's physically strenuous work, but it demands extreme attention to detail. And here's something fascinating that directly plays into human factors: the time breakdown. Because of all the paperwork, the safety sign-offs, compliance checks, meticulous logbook entries, AMTs often spend more time getting ready for a task and then documenting it afterwards than they do actually turning the wrench.
Huh. I never thought about that. That admin load, that must create its own kind of pressure, right? Like rushing the hands-on part to get to the paperwork.
Absolutely. That push to hurry the physical job so you can meet the documentation deadlines, that's self-induced pressure, and it's another one of those factors we constantly have to watch out for. That split focus between the tool in your hand and the logbook waiting for you introduces risks that pilots or controllers just don't face in the same way.
Okay, this inherent conflict, it leads us perfectly into probably the most famous tool for this: the dirty dozen.
Ah, yes, the dirty dozen. Every single AMT student needs to know these inside and out. They came out of work by Transport Canada back in the late 80s, early 90s. They basically distilled complex reasons for errors down into 12 common recognizable factors, things that degrade your ability to work effectively and safely. And the point isn't just memorizing the list. It's about recognizing the symptoms in yourself and others and then mitigating that risk before it turns into one of those latent, hidden problems.
Right. Let's maybe focus hard on four that seem particularly critical for students to grasp right away, starting with the one that seems to break the safety chain most often: lack of communication.
Oh, lack of communication is lethal. Particularly, as you mentioned earlier, during shift change. You've got a job half done, responsibility is shifting. If the person leaving doesn't clearly, thoroughly explain what they did, what they found, what still needs doing, the next person might make assumptions. And assumptions in maintenance can lead straight to catastrophe, an omission waiting to happen.
So what's the fix? What's the non-negotiable mitigation strategy here?
It has to be rigorous. You need both oral and written turnover, period. A technician shouldn't just pick up where someone left off without a proper handover. That means a face-to-face meeting, or at least a phone call, plus a detailed review of the paperwork. You know, it reminds me of the callback or challenge response systems used in medicine and even on the flight deck, saying scalpel, hearing scalpel back. It forces clarity, stops assumptions cold.
Makes sense.
Yeah.
Okay, next one, complacency. This one feels really tricky because it doesn't stem from messing up, but from succeeding.
Exactly. It's insidious. Complacency is that sort of self-satisfaction, maybe a false sense of confidence that builds up from doing the same thing over and over successfully. The danger creeps in when you're doing a routine inspection, let's say a 50-hour check. You've done it dozens of times, never found anything wrong, so you start to think, this part's always fine, and maybe you glance instead of inspect. Or worse, skip a step. That mental shortcut is a killer.
The book's advice is always expect to find the fault. That sounds good. But practically, how do you maintain that mindset after the 100th time finding nothing?
It takes a combination of things. Organizational measures help, maybe varying the inspection routine slightly or requiring a second set of eyes, a peer review for sign-off on critical tasks. But for you, the individual technician, the mitigation is constant vigilance. Stay mentally present in the task. And the absolute golden rule: never ever sign off on work that wasn't actually done or properly inspected. Read the task card, confirm the work, then sign.
You mentioned the night shifts earlier, fighting the body clock. That brings us straight to fatigue, the universal focus killer.
Yeah, fatigue is a huge one for AMTs, precisely because of shift work, often forcing them against that natural rhythm. And its effects are well documented. It dulls your cognitive abilities, slows down decision-making, hampers reaction time, makes you less alert overall. Classic symptoms can include like short-term memory issues or getting hyper-focused on some minor, unimportant detail while missing the big picture.
And our bodies are actively working against us during those shifts, aren't they?
They absolutely are. That circadian rhythm you mentioned. Your performance naturally bottoms out in the wee hours, often between 1 a.m. and 3 a.m. That's when you're biologically primed for sleep, dangerously drowsy. Yet, that's peak time for a lot of heavy airline maintenance. AMTs are required to do complex, safety-critical tasks right when their bodies are screaming for rest. And while there are regulations like 14 CFR Part 1, Section 377, mandating only 24 hours off per week, frankly, that's often not enough. It really puts the responsibility back on you, the individual, to manage your sleep. Aim for that recommended 8 to 9 hours.
Okay, fourth critical one: pressure. This feels directly tied to the operational realities of airlines, keeping planes flying, schedules met.
Absolutely. Pressure often comes from those tight flight schedules, the economic need to get the aircraft back into service quickly. Financial constraints can play a role too. The warning sign here needs to be flashing bright red. Never let time pressure compromise quality or safety, ever. Mitigation involves, first, recognizing when pressure is self-induced, that feeling of, I have to get this done now. Second, it's about communication. If a deadline seems unrealistic or unsafe, you have to speak up. Talk to your supervisor, explain the situation. Asking for help isn't weakness, it's professionalism.
So those are four huge ones: communication, complacency, fatigue, pressure. But the list is the dirty dozen. There are 8 more we need to at least touch on.
That's right. They round out the picture of common vulnerabilities. So, quickly, we also have lack of knowledge. That means always using the current, correct technical data. Realizing it's always better to ground the plane than to guess or use outdated info. Then there's distraction, both physical interruptions and just, your mind wandering. The rule here is crucial. If you get distracted, go back at least 3 steps in your procedure before restarting. Studies show something like 15% of maintenance errors are linked to distractions.
Okay, what about factors involving how people work together or the tools they have?
Good point. That covers lack of teamwork, poor coordination, not sharing vital information effectively, and lack of resources. This could be anything. Missing parts, the right tool isn't available, inadequate technical manuals, maybe even not enough qualified staff. Think about an AOG aircraft on ground situation. The pressure for resources there is immense.
And then there are factors about the technician's own ability to interact within the organization.
Yes, lack of assertiveness. This is about your willingness and ability to speak up, to voice safety concerns, to push back respectfully on unsafe or unrealistic demands from management, explaining why something is a risk. And of course, stress. This could be physical, too much noise, poor lighting, psychological, maybe financial worries, family problems, or physiological, poor diet, not enough sleep, illness. Stress just makes everything else worse. It's a catalyst for errors.
The last two seem deeply embedded in the workplace culture itself.
They often are. Lack of awareness, simply failing to recognize the potential consequences of an action, or sometimes inaction, just not seeing the downstream risk. And maybe the toughest one to crack: norms. These are the unwritten rules, the way we do things around here. Often they're shortcuts that maybe save time but compromise safety. The danger is when a risky shortcut becomes accepted, becomes the normal practice for the whole crew, especially when new technicians see veterans doing it.
Okay, so we've identified the risks with the dirty dozen. Now, how do we manage them? The course introduces some frameworks. These seem important because they shift focus from blaming individuals to fixing the system.
Exactly. That's the key shift. Let's start with the PEAR model. It's a useful mnemonic, PEAR, for thinking about the different components of a human factors program.
Right. P is for the people doing the job, their training, health, experience.
E is the environment. That's both the physical workspace lighting, temperature, noise, and the organizational environment, the safety culture. A is for the actions they perform, the actual tasks. These need to be well-defined, often based on a job task analysis, or JTA. And R is for the resources needed. Tools, yes, but also technical data, adequate time, qualified personnel, test equipment, everything required to do the job right.
Next up, MEDA, the Maintenance Error Decision Aid. You mentioned this moves away from the blame and train cycle.
Yes, MEDA is really a philosophy embedded in a process. The goal isn't punishment, it's prevention. Preventing the same error from happening again. It's built on really 3 core ideas. First, positive employee intent. Assume the technician was trying to do a good job. Second, errors usually result from multiple factors, not just one simple mistake. Third, these contributing factors can be identified and managed. So the MEDA process involves carefully interviewing the technician involved in an error, not to blame them, but to understand all the contributing factors. Was it pressure, lack of resources, a confusing procedure? Then you fix those systemic issues.
And the last model is SHELL. Use more for investigating errors after they happen. How does knowing this help me as an apprentice?
Knowing SHELL helps you think systematically about all the elements that could contribute to an error, whether you're analyzing one that happened or trying to prevent one. It forces a broad look. SHELL stands for S, software. That means procedures, manuals, checklists, even computer interfaces. H, hardware. The aircraft itself, tools, equipment, accessibility of components. E, environment. Lighting, noise, temperature, time pressures, shift work. But the core, the center of the model, is L, liveware.
The human element again.
Precisely. The L represents the individual technician, their skills, health, stress levels. And critically, it also looks at the interface between different people. LL, interaction. How well does the team communicate? Is training adequate? Is supervision effective? It maps all the interactions.
It's one thing to talk about models like PEAR or SHELL, but the real impact comes from understanding the stakes. The course examples are chilling reminders.
They really are. Think about Alaska Airlines Flight 261 back in 2000. A horrific crash traced back to the jack screw assembly in the horizontal stabilizer failing. And why did it fail? Because a critical lubrication task, something mandatory in the maintenance schedule, was repeatedly skipped, deliberately omitted over time. That's a failure to lubricate, a basic omission error, likely driven by factors like complacency, maybe norms, perhaps pressure. That simple oversight allowed a catastrophic failure to build silently within the aircraft.
And the Lufthansa A320 incident in 2001, a very near miss.
Terrifyingly close. The plane almost crashed right after takeoff because the captain's side stick controller had reversed electrical wiring. The co-pilot's controls were fine, thankfully, which saved them. The investigation found that during a maintenance task involving pin replacement, 2 pairs of wires got crossed. A straightforward commission error doing the task incorrectly. These aren't theoretical risks. They are real events with devastating potential, directly linked back to these human factors. Safety really relies on the technician's performance and the system supporting them.
So if we circle back to that initial statistic, roughly 80% human factors, 20% machine failure, historically, the student's role becomes crystal clear. They are the first line of defense in breaking that chain of human error.
Absolutely. The chance of an accident drops dramatically if that error chain gets broken right there
Yeah.
at the maintenance level. And for anyone wanting to learn more, keep learning, the FAA has excellent resources online. Check out hf.faa.gov and also fosssafety.gov. Constantly updated, really valuable stuff.
This whole discussion really boils down to one key idea. Error itself might not be totally avoidable, but it is absolutely manageable. So here's something for you, the AMT student, to really think about. Knowing the dirty dozen now, which one of those factors might be most present in your own study habits or maybe your current work practices? Is it self-induced pressure to finish assignments quickly? Maybe fatigue from balancing study and life? Complacency on topics you think you know? Identify it, and then what specific concrete mitigation strategy are you going to put in place starting tomorrow to break that potential chain for yourself? Mull that over as you continue your training. Thanks for joining us for this deep dive.